pressure a bit. Watch those. That glow discharge. I've cleared off this space. I think this is going to be generally where I set up and build the fusor and where it's going to live. Well, it's on this bench. Initially, I had all this optical stuff that I've been piling up for a while over here. This was kind of the optical hoard bin, I suppose. But now I'm gonna have this right side basically just be specifically for the fusor. And something that I realized is I have this chamber that's been kind of sitting around. It's pretty unique. It's got a bunch of these little 1.33 inch conflat entrances on this one side, 5 of them. And then it's kind of this spherical chamber. And it has more volume inside of it basically than one of these 6-way crosses. So I'm going to build with this as the central chamber for now and kind of see where that takes me instead of this 6-way cross. And the small conflat side is going to be my gas inlet side where I'm going to use this leak valve. I gotta test this, make sure that it actually works. So deuterium is going to come in on this side. I'm going to be pumping from this side where the viewport currently is. I'm going to remove all this and clean this guy up. But yeah, so deuterium from this side, and then pumping out that way, which should carry the stream of gases right past the fusing grid. Here's the piece, the central chamber. I removed all the fittings and stuff that were on it, except for these 3 blind flanges, because I'm just going to keep these on, because I'm not going to, at least for now, have anything here. In the future, maybe I could use these ports for some weird ion gun stuff or something like that for fusion enhancement. We'll see. But for now, I wanted to get this more or less down to just the chamber itself. And it's pretty gunky. I think this must have been used for some kind of deposition work or something like that. There's a lot of sort of thin layer on the inside here. I don't know if it's coming through really on the camera, but kind of like thin film interference type of stuff. So maybe they were using it for some kind of deposition work, surface science, whatever, stuff like that. But I'm gonna throw this in the sonicator. I'm gonna try and get this cleaned up as best as I can. Same with this viewport that was on it. You can clearly see deposits, metal deposits of something or other left over. So we'll see how that goes. I'm just using, I'm going to heat it to 50°C, sonicate it for 15 minutes for now, see how it does, using some distilled water and ethanol for the cleaning. Went ahead and sonicated a few of the main pieces and baked them out that I'm going to use for the chamber and whatnot. Here's the main central chamber piece. This is a pretty unique UHV piece. Hopefully it'll work fairly well for this. It's probably going to work better than a cross, than the 6-way cross that I had originally thought that I was going to use. So this is going to sit basically in this orientation. actually, let me think here, it's gonna be this way, and vacuum from the right, then gas inlet from the left. Here's the turbo that I'm going to use, and I put this reduction piece converter to a conflat here, and then just this bobbit angle valve to isolate the turbo whenever needed. One of the things that I want to figure out is proper height standoff basically for this high voltage feed through, because I would prefer not modifying this feed through in any way if I can get away with it, just for future, if I want to, you know, use it for something else in the future. I would prefer not to, you know, cut this down or anything like that. And so I'm gonna try and find a fitting that will stand this off just enough to keep, you know, the electrode above, and then I can get the rest of the way with the grid basically. So I just have this thrown together with a couple used gaskets just to show kind of the idea of standing off the feed through here, and so I don't have to cut the electrode down. I don't know how easy it is to see, but there's the electrode sticking out down there right in the middle, centered fairly nicely. I am a little bit worried about potential arcing between this wall and that electrode, but I guess we'll burn that bridge when we cross it. So yeah, this looks pretty good. I think I am going to go with this setup for at least this feed through part, and we'll just keep going. Again, the plan is to have the gas inlet here coming through this. I'm actually going to use this hose over here for that, so that way I can have the actual valve kind of farther away from the operation. And I might even put a high voltage standoff fitting here. Here's the grid that I'm working on, made out of nickel currently. I'm just using this spot welder to weld this thing together. It's not the prettiest looking thing. I was trying to use tungsten earlier, but I think I'm gonna have to actually shield it with an inert gas to spot weld it properly, because I think it just, with how hot you gotta get it, it's oxidizing a ton and gets super brittle, and just doesn't look very good. And I think making multiple rings of it would be very tough with how brittle it becomes. So yeah, for now I'm just gonna stick to nickel, maybe get some stainless steel as well to play with for these. Here's another ring that I'm spot welding of nickel. So the nickel ends up melting relatively easily. This weld isn't, nope, it kind of came apart. Try that again. But yeah, this is the process that I'm doing to make these. There we go. I think that about did it. It's a little bit tedious and the results aren't super pretty, but I'll polish down, you know, sand down the weld to make sure it's all smooth so there's no points, you know, field concentration points on the ring that could cause arcing and whatnot and bad performance. I'm just gonna Try and use the Dremel here to smooth the weld out a bit. So here it is now. I don't know how easy that is to see, but it's smoothed out, and I'll probably use this stone to polish it a bit as well. The idea here is to get everything as smooth as reasonably possible, because again, any sharp points, you're going to create a strong field in that spot, and so it could, cause easier arcing from that sharp point to the chamber wall, and we definitely don't want that. Okay, now for the tricky part of actually welding this ring to the rest of the grid, because if I mess this up too bad, I'll have to start all over basically. So unfortunately, these electrodes are too big for me to be able to get inside to make these final welds. The third ring appears to be fairly well captured, so I might be able to just get away with using this for the first few tests, at least for trying to see if I can hit the so-called star mode and whatnot. But in the meanwhile, these, you can swap out the tips here. They come right off. So I'm going to see if I can find some kind of longer, thin tips to use on this setup that will allow me to actually get the electrodes in to make this weld. So here's how I'll be attaching the grid. I'm gonna have to cut this post down a bit, but the grid will attach with this little slip-on connector to the main electrode feed through. It just slips right on and it'll sit there. We'll see how well this works, because there are some pretty sharp edges on this guy that might create field issues in the neck of the feed through and cause arcing. I'm just not sure about that, but basically the feed through attaches at the top, and it'll come down and suspend the grid right in the middle, or as close as I can get it, at least. That is the plan. I just finished kind of the main build of the fusor, and here's the actual kind of body where the fusion will be happening. I've got the electrostatic grid in there. I don't know how easy. Oh, there we go. It's just some 1 millimeter thick nickel wire that I spot welded together. Definitely won't be wanting to use that for actual kind of fusion runs, because it will very likely melt rather quickly. Melting point's just too low, and it sputters and stuff, so not the best. The overall layout is relatively straightforward. I've got the main body here. It's this custom piece that I forgot that I had. I had it attached to some other. It came off a system that I bought a while back, and I tore it apart. But this piece is really cool because it's sort of like a 2.75 inch conflat cube, kind of, but it has this side, which is all the mini conflats. It's got 5 mini conflat connections here. So I'm going to use this side as my gas inlet, eventually being controlled through this leak valve. I haven't tested this. This came off another piece of the system. So a lot of these pieces I've just had sort of laying around in mothballs and storage. So this is going to be a first time test for them to see if they actually hold vacuum, if there's any issues, especially this leak valve. Because if this works, this will be a really, really nice way to precisely control the amount of deuterium entering the system. We, of course, have our high voltage feed through. I think this thing is definitely rated to at least 30 kV, and it should be able to push 50 through it. Although with a system this small, I don't know if going much above 35 would even be realistic before I start seeing breakdown. I've got one window here and then a second window here. They're both, angled down basically at about a 45-degree angle, and that's by design, so that way, x-rays mainly are pointed more or less at the ground, so there's not too much of like an irradiation path from the view ports. And eventually I'll set up some mirrors on optical posts and whatnot to be able to do good recordings of what it looks like in there without exposing the camera detector straight to the radiation, to direct radiation. So that's the two viewports. And back here I have this T, which initially I thought I would put a couple different gauges on, but for now I just have one side blanked off. The other has a full range gauge on it, and the way these work is, it uses, I want to say, Polarity up front until you get to maybe low -3 torr, E-3 torr range, and then it switches over to an inverse magnetron, which then can take you all the way to the -9-ish range. Probably won't be getting that low with this system for pump out. And then I had one of these standoff pieces. This is a piece of ceramic. So it's made to stand off, like to isolate basically electrically between this side and this side. And even though I'm gonna have the entire system grounded from the body, I figured since I have it, I may as well throw it in, because if I have this part grounded and then this part will also be grounded, if I didn't have this and I had an arc or something happen, there's a chance that maybe on its way through, to ground, it could mess with the electronic controls of the turbo, which really wouldn't be great. But this could potentially give me extra insurance of that not happening. I mean, that could still happen, through a ground loop or whatever, but this would maybe give an extra bit of protection against messing with electronics on this side. And then we've got the vacuum system, which is a turbo backed by a dry diaphragm pump. I like these dry pumps because, in case something happens, you're not potentially pulling oil back into the turbo and destroying the turbo. So first order of business with this thing is to try and pull vacuum. So I'm going to try and pull vacuum here. I've got this isolation valve, and unfortunately the way that I have this controller set up right now, I have to basically just plug it in for it to turn on. But first we're going to use just the roughing pump and see. Okay, so it's definitely pulling down, which is good. And before we turn the turbo back on, or turn the turbo on, is I want to test this leak valve just to make sure that it's, because if it's totally broken and I were to try and test this with the turbo running, it could crash the turbo, because if this thing just opens up to the atmosphere really quickly without fine control, you could easily kill the turbo. Okay, so this looks like it should work. Okay. Okay, now I'm going to plug the turbo in. Let's see how this does. It's going to be a bit loud because it's mainly the cooling fans, ironically. The turbo itself is pretty quiet, but I don't know, you might be able to hear the high-pitched noise. It's very quiet, but as it spins up, it's gonna make some kind of higher pitched noise. Okay, this is a good sign. It's you know, it's pulling down pretty quick as it's spinning up, because it's not at full speed right now. Okay, -4 already. Yeah, this is looking pretty good. Definitely don't have any major leaks, I don't think. It's always nice when first putting a system together, because with the amount of connections and stuff, sometimes you just miss something stupid or have a hair or something and messes up a seal. But so far, this looks pretty good. And the way I have this thing mounted is kind of wonky. So at first I figured out that, you know, I can use these threaded holes to put attach mounting posts, but they're all sort of at a 45-degree angle to the main connections. And so, you know, I can have this central post, which worked great, but it wasn't totally stable. And so I added another one at the top and had one of these aluminum bracket pieces laying around that I drilled out the original holes of to accommodate these quarter 28 bolts, thread-hole bolts. And then I just used another optical post back here to support it. So now it's very sturdy. I mean, this thing on this optical plate is perfect. I'm going to see how much control I can have with this leak valve here. It's at least sealing, which is good. There we go. Okay. So I would say this leak valve definitely works, because see, being able to control it like that finely, that tells me that the sapphire sealing piece in there is still good. It's not cracked or anything like that. It seals well, so that's fantastic. And look at that, we're already getting into the lower -5s. This is very promising. I'm super happy with this. Well, I've let this thing pump down for about, I don't know, a good hour and a half or so at this point, and it's in the low -6 now, which I think is pretty good. There might be a small leak somewhere, I'm not sure, but this is doing pretty damn well at this point. And I did I couldn't resist. I played with it a little bit voltage wise, and I think we might be able to get star mode going, which will be pretty cool. I set up my little, high voltage power supply. It's a very janky thrown together one, but it'll work for this. And it's just, I've got a little signal generator with a MOSFET in there that's switching the low side to the high voltage transformer, and then that's being fed into this DC rectifier, which is rated for about 20 kilovolts. Not really pushing anywhere near that. And we'll see what we can do here. First step will be to get this pressure higher so we can actually ignite the plasma, and then hopefully I can get some kind of cool shots with this guy. Of the actual plasma. So we'll try that. I'm going to put this over here. Turn this power supply on. So first thing to do is kind of get a balance going of the vacuum being pulled versus the amount of gas that I'm letting in this case just being atmosphere from the leak valve. So I'm going to mostly close this valve to the turbo to kind of impede the pumping to the turbo, but not fully close it. Back it off just a little bit. Now I can use the leak valve to up the pressure a bit more in the chamber. We're looking to hit around 10 to 30 millitorr range. So basically we want to see, -3 over here instead of -6. Okay, so there's about 13 millitorr. We will it's not very stable. There's 10 millitorr, 20 millitorr. I think I'm gonna start at 50. So we can kind of go through the different stages of plasma discharge. So I think that'll be kind of interesting to look at. So I'm going to try and focus this other camera a little bit better. Seems a bit better. Looks like I'm not getting a totally stable discharge here, and I'm not sure. It might be because I don't have quite enough capacitors to even out the ripple. So I'm going to try and hit about 20, I'm at 19 millitorr right now. I'm going to start upping the voltage a bit. close. Yeah, it's kind of flickering on and off, and I'm hearing something clicking on the power supply, so I might be shorting, or like partially shorting somewhere, maybe having some corona. I'm not sure, but this does seem to be working. That is pretty neat. I'm going to turn the voltage down, and let's up the pressure a bit. Watch those. That glow discharge. So there's 57, 59 millitorr. There's 160 millitorr. So I reversed the polarity, and it made the chamber itself, I guess, negative relative to the grid rather than the other way around. And so the ions, the positive ions are being launched at the chamber rather than towards the grid. So this might be an effective way for me to potentially kind of clean the inside of the chamber, is to run in this mode for a while. I don't know if you can see, but there's these little spark discharges every once in a while of stuff getting blasted off the surface. Might be a good way to clean up the chamber a bit, especially for the future when I'm actually trying to run deuterium through. It might matter quite a bit to have a really clean chamber to increase neutron yield, basically, fusion rate, because anything that you have in there that's not deuterium, that is in the gas phase, interfere with the thing. Back to so yeah, I think it's pretty safe to say that the setup is working for sure, and it's, I don't know if I can necessarily call it quite full-on star mode yet, just because my power supply is having issues maintaining a continuous output right now. It's doing fairly well for what it is. I mean, it's just a thrown together little thing, but I am very confident in this setup being able to handle a proper power supply and actually having good enough control with that leak valve and then this isolation valve to maintain a set pressure inside of the chamber itself of whatever you want, because I can dial that valve really well. It's super sensitive, So you know, you got to be careful with it, but you can almost just pick a specific pressure point, and it will maintain it. Here, I can actually, I'll go ahead and show that here in a second. So we've got 18 millitorr. Now we're down to 16. 9.7 millitorr. Now if I go back, you know, I can dial it up to pretty much whatever I want. We're at 20 now, so I can take it to 30, 40, 50, and same goes with lower pressures as well. So you know, now I'm in the 6 millitorr range. Going down. And let's see if we can actually get it to stay right above 1 millitorr, right on that edge to -4. Yeah, I mean, this is working beautifully. I'm really happy with this valve. It's a little surprising that it's still in good shape. Usually components like that, when I pull them off an old system, they're just, you know, from an auction, they got beat up, whatever, but this thing is definitely functioning properly. Okay, so now we're in the -4, so you know, it gives you the kind of control, tiny leak rates where you can still have control. Here, well, let's go into the -5 just so I can show you where this is very low pressure. So you know, having a controlled leak rate that allows you to control numbers in this range, it really speaks to how, you know, precisely engineered these valves are. So we're at 6 now. I can tweak it a little. Go down to 5. Yeah, and these are made to where you can operate them even lower and still get a controlled leak rate. So this is great. I think we're well on the way to being able to do proper fusion here, as far as the fusor is concerned. I don't like how this is getting a little squished, but that's all right. Yeah, I think this is gonna work. I'm gonna be able to do some interesting experiments. The challenge is for sure going to be for me to build a proper power supply for this. It's gonna be a bit tricky, but we'll see. I'm gonna try and use this same architecture on the rectifier side, except basically, you know, triple everything to make a 60 kV rated rectifier to be able to take the output of a much larger transformer, and hopefully just have, you know, a 0 to 35 kV controlled high voltage output without doing any multiplication, you know, voltage multiplication steps. That would be really nice. So that's kind of my plan for the power supply. And yeah,